All right, so partial variations. There are some properties of partial variations. So graphs of partial variations are straight lines. Unlike direct variations, they do not pass through the origin, but they pass through the point 0, f, where f is something on the y-axis. And they increase in value as you move to the right along the axis. So just as a brief, quick sketch, it's going to look something, oops, on the alignment here, something like that, where it's not going through the origin at the bottom, but it does still have a straight line, and it still increases as you move to the right. So in general, partial variation is represented by the formula y is equal to kx plus f. Again, should be familiar to most of you. Remember yesterday we said that instead of using m for slope, they use k for constant, but it's the same thing. So y is equal to mx plus b. What was b in pre-calc? The y-intercept. So what do you think f is in this equation?
B.
It's the same as b. It's the y-intercept. It's where it crosses the y-axis right there. That was just so I could line it up. All right, so here's a quick example. Now this is just one. You got a basketball team. There's a fixed cost to send the team to the tournament, plus a price per player. Very common. I mean, if you look at renting a hall for a party or a social or something, you have a fixed cost usually to rent the hall, and then you have to pay per person. If you're, having a kid's birthday party, sometimes they charge you a fixed cost to rent a room, like at Kid City or something like that, and then there's a cost per kid that goes. Movie theaters, there's lots and lots and lots of different examples. They're all figured out basically the same way. So here we've got the cost of sending a basketball team to a tournament involves fixed cost per player. And then it gives you some information. It says, well, to send 10 players costs you $490, while the cost of sending 12 players is $550. Now, right off the bat here, it asks you to find the partial variation formula. So you need to actually figure out what are my constant of variation and what is my fixed cost. Okay? So the first thing I always do with any of these problems is write out all my variables. Now, if you remember yesterday, they gave us some variables for the volume and cost of water. Did they give you variables to use here? No. If they do that, if they leave it, you can either make up your own variables, probably cost and number of players, so I would use C and P, or you can use X and Y in this case. Because they haven't assigned you any, you can say X and Y, where Y is equal to whatever and X is equal to whatever. So if variables aren't assigned, then you can use X and Y in a general formula. But I would usually make one up, okay? So let's start by writing out, all of our variables. So the general formula, y is equal to kx plus f. I almost wrote b there for a second. We've got 4 variables, 4 things we need to figure out. So what is our y, or our dependent variable in this case? Yeah, total cost. Total cost depends on how many players we send. So in this case, our dependent variable is total cost. So I'm going to say y is equal to total cost. And you'd usually want to include some units, so total cost in dollars. So if y is our total cost, then what do you think x is? Yeah, number of players. So x is equal to number of Come on, keep up with me, smartboard. Players. All right. So you've got total cost, you've got number of players. What's K? Constant of variation. Now, in this case, computer's getting a little slow. In this case, what does that represent? Our constant of variation. We're multiplying it by the number of players, so it is cost per player. Excellent. So constant cost per, and then F. What do we think F is? Our fixed cost. So in this case, it's the entrance fee to the tournament. So if they charge $100 to enter the tournament and then $10 a player, you just figure it out that way. Now that's not what it is in this case. We're going to figure out exactly what they charge. Fixed cost. Yes. Yes. I'll post this on. Okay. So now what we need to do, this is going to be kind of a longer video just because I want to go through, have this entire example on there, but if you do want to go back and look at it, you can. Now what we need to do is we need to take the information they give us and put it into these formulas. Okay? So it gives us a total cost for 10 players and it gives us a total cost for 12 players. And we need to figure out the fixed cost and we need to figure out the constant. So the way we do this, that's two variables we need to figure out. We've got two variables and two equations. So what we do is we combine these two. All right? So we'll go through this one together. What I like to do, this is the way I learned it in grade school, was to line up the two equations one on top of the other and then subtract. So I always like to make sure I take my biggest numbers and put them into the top or the first equation. So in this case, the biggest numbers are 550 and 12. So total cost of 550 for 12 players. So I substitute that into my general formula here. So I'll switch to blue. So that is Y is 550 is equal to K, I don't know, but how many K? 12K, because there's 12 players. 12 players cost us $550, so 12 times X, 12 times K.
12 is K.
No, 12 is X. Sorry, I just like to flip it because I like to put the number in front and the variable behind. You can do that with multiplication. Okay? So I've got 12K plus F. I don't know F yet. And I don't know K. Rita?
You meant like with the two equations you just do one.
Well, yeah, this is the first one. And now we're going to do the second one. So now I use the second one. I've got 490. It's my total cost. Is equal to 10K. So I've got 10 players. Plus F. Now, the nice thing about these partial variations is it's always going to be 1 F. They're always going to work it out that way, and it'll always cancel nicely. Okay? So now we can combine these two equations by subtracting. Okay? So you just go through with each one and you subtract. So I've got 550, subtract 490. That leaves us 60. Just before lunch, I know, but still got to work on that mental math a little. All right, so 550 minus 490 gives us 60. Okay, 12 minus 10, 2K. So 12K minus 10K gives us 2K. F, subtract F gives us no F's. Or you could rewrite that as 1F and 1F. So 1F minus 1F, I'm left with no F. So now I've got 2K is equal to 60. Divide both sides by 2.
Okay, so the fixed cost is 190 then.
So hold on. K is equal to 30. Okay? So go back. What was K again? K was our constant, and it is our cost per player. So to enter this basketball tournament, if you want to bring one player, it's 30 bucks. If you want to bring 2 players, well, 2 times 30 is 60 bucks. 3 players, 3 times 30 is $90. So that's our cost per player. But we still haven't paid our entrance fee. There's still a little matter of having to pay to enter the tournament in the first place. All right, so now we've got K. We can substitute into one of those 2 formulas and solve for F now. Okay? So I'm going to just substitute into the first one. Doesn't matter which one, you'll get the same answer. So I'm going to go 550 is equal to 12 times K. Now I got a value for K, it's 30, so I can put in $30. Plus F. So now we got this equation with just one variable, we can solve for it. So 12 times 30, 360. Take away from 550. And you're left with 190. 190 is equal to F. So that is our fixed cost, is $190.
That's our interest rate. Okay, just
Yeah. Whether you bring 1 player or 100 players, you have to pay $190 up front.
What's the interest on that?
So, well, you're getting ahead of us, Carla. So now,
Sorry, I was just going again.
it asks us to write out the formula, so now we need to write out our formula with everything that we've solved. So originally we had wrote y is equal to kx plus f. We now have values for k and for f. So the actual final formula is y equals $30 per player. It's supposed to be an A. Times x plus 190. Okay. So y is equal to $30 per player times x plus $190. That's our general formula. So that's the answer to A. So that was a lot of work just to write out. We still have a B. But now B is relatively easy because if you look, find the cost of sending 20 players to the tournament. Well, X is number of players. So now we want to know the total cost for sending 20 players. So B, you go Y is equal to $30 per player. I'm just going to shorten that to 30 over P. So $30 per player times 20 players plus $190.
Do we have to put in the
I would always put in your units, because if you don't put in your units, if you just write numbers, then it's very easy to get confused. If you actually take a look at what you've got here, when you write out exactly what you mean by your variables, and then you get through all of this mess over here, and you get to the end and it says k is equal to 30, and you just write that number, then you might then look at it and say, okay, well, what the heck was k again? If you've got your key over here, then you can actually look at it and say, you don't have to go back and reread the whole question or try and figure out, well, what was I actually doing here? If you've got it all written out, if you write out your variables and what each of them means to you, not only does it make it easier on you, it makes it easier on me when I'm marking it, and it gives me an opportunity to give you some more marks. Okay? If you just write k is equal to 30 without any units or any showing any work or anything, I can't give you any marks because that's not the right answer. That's basically. All right, so how much does it cost to send 20 players?
$790.
$790. All right, that's